I want to just do a quick video here about some of the shortcuts that I've been getting some questions, and I've been seeing others pose questions online about sizing systems, sizing ductwork for a new system, trying to figure out if there's any shortcuts, any ways we can streamline the process. And there's a lot of rules of thumb out there, and there's a reason why rules of thumb are rules of thumb. Is because they work a lot of the time, but they don't work all the time. So one of the rules of thumb that you may have heard is that you can take your tonnage of AC times 400, so 400 CFMs per ton, and you get your total airflow for the system. And then you divide that up equally amongst the square footage of each room, and that's how you can equally distribute the airflow. And then you size your ducts accordingly. And again, there's a reason why that's a rule of thumb. It works a lot of the times. But I've got something pulled up here on my laptop here using RightSoft, just an example house. And I'm going to show you why it may be potentially very risky for your project if you use that rule of thumb. Let's take a look. So here we have a typical house layout. I haven't done anything to doctor this layout. This is your typical ranch house that we see everywhere. In this case, it's 2,077 square feet. And it's in Charlotte, North Carolina, 1990s construction. And if you notice, I've got CFMs for each room under the room name. So the living room is going to need 379 CFM. Of course, you're going to have to divide that into multiple supplies. And the master bedroom is going to require 184 CFM, and we'll probably divide that up at least 2 supplies there. And notice what my cooling and heating BTUs are. So total cooling BTUs is around 25,000 BTUs. Total heating BTUs is around the same, 25,000. If you notice that the front door faces east. But notice what happens when we simply rotate this house 90 degrees, where the front door now faces north instead of east. Notice what happened to the CFMs required for our living room. They went down drastically, 274 CFM as opposed to around 100 CFM more when we had the house at the other rotation. And notice the master bedroom. It now needs way more CFMs. We were at 184 before, now we're at 223. We might even have to put 3 supplies in this master bedroom. And the only thing that changed was we rotated the house. So if you walk in and you are going to do an install on this house, you may be tempted to just take the airflow and evenly distribute it per the square footage of each room. But as you can see, that distribution really changes based on simple factors like how they oriented the house on the lot. Okay, in this next slide, we've taken the same house and we've plucked it out of Charlotte, North Carolina, and we've set it down in Ohio. Nothing else has changed, not even the orientation, simply changing the location of this house. Notice that our cooling BTUs went down and our heating BTUs went up. But notice what happened to our CFMs in our living room. Remember, it was in the 200s before. Now we're at 364. And in the master bedroom, we're at 314. So again, if you just walk into this house and you want to evenly distribute this air according to the square footage of each room, it's not going to work for this layout. All right, so we take the same house, we pluck it out of Ohio, and we set it down in San Antonio, Texas. Nothing else changes. We set our orientation back to where the front door faces east. And notice that our cooling BTUs went all the way up to over 27,000. So probably we're going to have to go up at least half a ton in the equipment that we put in. But our heating BTUs went way down. Well, that makes sense because it's Texas. Their winters aren't as cold. But this goes to show that we can't really have any rules of thumb about square footage per ton. And really, that's only affecting air conditioning. A square footage per ton does nothing for heating. But I want you to take a look at the living room now. Living room, we're back at over 300 CFM. The master bedroom went down to 156 CFMs. So there are a lot of changes that can take place just by rotating the house, depending on which direction glass faces. And there are so many other factors that we haven't even covered, like the type of insulation that's in the house, how well built it is, how airtight it is, where the ducts are located. There are so many variables. We simply cannot use rules of thumb to size units, size ductwork, or even estimate how much air is going to go into a room. So what did we learn? Well, simply rotating a house could make a huge difference in how many CFMs need to go in each room. Also, the location of the house, if you're in a heating dominant climate versus a cooling dominant climate, could have a big effect. What kind of furnace are you using? An 80% or a 90%? Are you using a heat pump? All the different airflows change according to what kind of equipment that you're putting in. So simply showing up to the job and sizing your ducts according to your air conditioning CFMs per ton is not a great idea, because in a lot of places, especially heating dominant climates, and that includes parts of the South, that your heating CFM may actually be more with a condensing furnace or even with a heat pump. Really the best way to approach a new install, and that includes a cut-in, a new install, a complete gut and replacement. Anytime that you're an entire system, you really want to follow the manual J load calculation, manual S system selection, and manual D duct design. That is the best way that you're going to get consistent results. Using rules of thumb are really dangerous, especially because these rules of thumb are pretty old school. Think about who taught you, maybe who taught them those rules of thumb. Equipment has changed, the temperature, the air coming out of equipment has changed over the years, houses have changed, there's all these moving targets. If we're still using those rules of thumb that we used 30, 40, 60 years ago, they're simply not going to work in a modern house a lot of the time. I hope that you understand that there are just certain shortcuts that we should not be taking. It would be sort of like your apprentice showing up one day and saying, hey, I left my tape measure at home, so do you have a shortcut for me so we do this job? Is there any way we can use like hand width and finger breadth instead of a tape measure and we can still make this job look good? What would your answer be? Would you even entertain the idea of replacing a tape measure with a shortcut using just your hand? Of course not. You would tell them that the solution is go home and get your doggone tape measure. So the same thing here. There are certain shortcuts that we can use. There are certain rules of thumbs that we can use, but we have to be really careful. So this is not to throw shade on anybody at all. There are a lot of people out here giving advice to the best of their ability, and they're willing to learn when they get some new information. And we're all trying to elevate our game. So say, for example, you're a really good technician, or maybe you're a really good installer. You do solid, good looking, clean installs. Maybe 2024 is a year that you elevate your design game. See, for me, I've been a good designer for many years. Now I'm trying to elevate other parts of my game that you may or most likely be better than I am. So we're all trying to learn here. We're not throwing shade on anybody that may have given advice. It's maybe not exactly right. We're all just trying to get better. So I hope this video helps. If you have any other questions about sizing units, sizing ductwork, I run classes in the spring and fall. You can direct message me anytime. If you work for a company and they want to hire me to do some consulting, some teaching, some design work, I'll be happy to do that also. I'm just here to help. So for now, thanks for watching, and as always, work safe.